Now this question, we have to find the equation of the circle that passes through the points z1, z2 and z3. So we've been given three complex numbers, z1, z2 and z3, each representing three distinct points. Let us suppose x1, y1, x2, y2 and x3, y3 on a circle. And we have to find the equation of that circle. Right? The second part of the problem, which we will deal with later on, is to find out the condition for a fourth point to be concyclic with these 3 points. Right? So the way to do this problem is that, first of all, if we are able to just find out the equation of the circle that contains these 3 points, then all that I would need to do in the end would be to put the fourth point into that equation in place of the z to find the condition for the fourth point to be concyclic with these 3 points. Alright. So I hope I have made myself clear. Let's move on to finding the equation of the circle that passes through these 3 points first. Okay. So on the next page, you will see that I have drawn a circle. Alright. This is the circle. And this is the point P whose locus I need to find. So therefore, I will name this as Px, y or just z, because this chapter is complex numbers. So in place of the x, y, it's better that we start with z as the premise of solving this problem, or the locus, finding the locus of this point. The other 3 points, namely A, B and C, are also shown on the same circle, okay, whose coordinates are z1, z2 and z3 respectively. Right? Now, since all these 4 points lie on this circle, right, I can say that the angle, right, subtended by this chord, okay, that is PB, right. Just for instance, I'm taking PB. The angle subtended by the chord PB in this segment of the circle, that is the angle PAB, and the angle PCB, that is the angle subtended by the same chord in the other segment. If I was to add these 2 angles, alright, what do you think the value of that is going to be? It's going to be 180 degree, right? Because the sum of the opposite angles in a cyclic quadrilateral is 180 degree. And moreover, had this angle been in the same segment, that is, had they been arranged like this, A, C and B, because I don't know whether A is going to be here or is it going to be here. If the point A would have been in this segment right here, then PAB angle would have been equal to PCB. Okay. So we are taking the worst case, that is in which A is lying in the other segment and C is lying in the other segment. So the argument of this angle plus the argument of this angle, right, is going to be, that is the value of this angle and the value of this angle is going to be equal to pi, right, or it will be equal to 0 had they been in the same segment. Alright. So therefore I can write that the angle BAP is equal to angle BCP. That is the best case. The worst case, A lies over here, then their sum will be equal to 180 degree. Therefore the argument of Z minus Z3 upon Z2 minus Z3, that is, how do you get the angle BAP in terms of Z, Z2 and Z3? Okay, Z, Z2 and Z3. How do you do that? So for that, Z minus Z3. Now look at this. Z minus Z3 basically represents this line given over here. And the Z2 minus Z3, okay, Z2 minus Z3 represents this line over here. So when I say argument of Z minus Z3 divided by Z2 minus Z3, then it is the angle enclosed between these 2 lines which I am talking about. Alright, that is this angle number 1 over here. Alright, so this argument represents the angle number 1. Argument of Z2 minus Z1, that is this line over here, divided by Z minus Z1, that is this line over here. If I was to subtract the slopes or the angles made by these 2 lines with the x-axis, I will get this angle number 2. So this would be angle number 2. That means angle number 1 plus angle number 2 is coming out to be equal to 0 or pi. Alright. I hope this is clear to you now. So now what happens is, by remembering the property of arguments, that the argument of Z1 plus argument of Z2, right, is equal to the argument of Z1 multiplied by Z2. Okay. So applying this rule, I will get this is equal to 0. So the argument of a complex number is 0. Alright. If you recall, for a complex number, r times cos theta plus I sin theta, if this is a complex number, and if my argument of that complex number is 0, alright, then z can be written as simply r times cos 0 plus I sin 0. And how much is this going to be equal to? It's only going to be equal to r. That means it will be purely real. So therefore, once I have concluded that this argument is 0, I can say that the complex number lying inside the argument is purely real. That means this quantity is purely real. That means that even the conjugate of this complex number will be equal to itself. And that's the premise that I'm applying over here. I put a conjugate on this entire entity and make it equal to itself. So z minus z3 upon z2 minus z3 times z2 minus z1 upon z minus z1 will be equal to the entire conjugate of this quantity itself. And this hence represents the equation of the circles passing through the 3 points z1, z2 and z3. So you got to understand that any equation that is written in terms of z and its conjugate can be considered as the equation of locus for the point z. Okay. So this is the required answer. And to the second part where we say that a fourth point satisfies this equation, right? Then in the next step, I can say that in place of the z, if I was to put a z4, and in place of the z conjugate, I was to put a z4 conjugate, then this would be the required condition. And hence, the correct answer, as you can see, is the part A.